Namaste. Welcome to this channel, Dr.ARM's Chemistry. We were discussing the study of chemistry of 3D elements. In this topic, we are now discussing the various points under the title of coordination chemistry. And the second point is we have last time discussed the electroneutrality principle, and today we will discuss coordination number. We will discuss coordination number and geometries. Of resulting compounds or and coordination complexes. In this point, we will see the overview about coordination numbers, and the second part of this point is geometries related to the arrangement of the ligands around the central metal ion. So our attention is focused on especially in mononuclear species, that is the metal ions present in the complex or compound is only one, and there are so many complexes in which the number of metal ions are 2 or more. So in that case, we consider the complexes or molecules as polynuclear complexes. But at present discussion, we are concentrating our attention on the mononuclear complexes or compounds. Here, the species are containing the nature of bonding is considered to be the covalent, in which the metal is bonded to ligand, and the nature of bonding is considered here is covalent. For considering the geometries and arrangements around the central metal ion. So if you see the structure of atom, we are considering that this is the metal ion. See, this is the metal ion and nucleus of this metal ion, like this. And these metal ions are surrounded by the ligands like this, in this way. So if we take the octahedral complex like this, then the ligands are bonded with the metal ions in this way. So here the metal, this is called metal ligand bond. This is called a metal ligand bond, and it is covalent in nature. Here the sphere around the nucleus in which the ligands are placed is called coordination sphere, and there is another sphere of attraction like this, in which still there are some ligands. See, there are 3 ligands for example. So this sphere of attraction is called ionization sphere. where some ligands are present in order to neutralize the charge existing on the ionic species. So here we know that the metal is Levy's acid and ligand is Levy's base. Here you will find that Levy's acid is electron pair acceptor and this is electron pair donor species. So in addition to this, the ligands are sometimes pi electron pair donors, and these Levy species are pi electron pair acceptors. So these metal and ligands behave in variety of ways, and the important part is metal is always Levy's acid, ligand is Levy's base, and during coordinate or covalent bond formation, ligand shares its electron pairs with metal ion. So Levy's acid metal is electron pair acceptor, and in that case the ligand is Levy's base, which is electron pair donor. But when there is additional bonding present between these ligands, like this, so this is pi and this is sigma. So we can say sigma electron pair acceptor also, and this is pi electron pair acceptor. So in this way, the complex or molecule contains metal ion at the center, ligands are arranged around the nucleus, and some ligands are also there which are present in the ionization sphere in order to neutralize the charge on the ionic species. So here this arrangement, so we have shown here the arrangement of 6 ligands around the metal ion, but there is always no 6 ligands around the metal ion. The number of ligands vary and depending upon that the arrangement is different. Now we will see what are the factors which are resulting in the arrangement or number of ligands around the metal ion. So the important factors responsible for the specific arrangement of these ligands around the metal ion are the size and charge on the metal ion. Similarly, the size and charge on the ligands is also important. If the ligands are smaller in size, the number of ligands vary. If the ligands are bulkier, then also the arrangement varies. So we will see how it depends upon each other. So first point means we cannot generalize about the coordination number present in every transition element, because the number of electrons present in the metal ion is different or metal atom is different. The size of the metal ion is also varying with nuclear charge. So there are number of factors which govern the coordination number. So first is the point important to be noted is that the coordination number cannot be generalized. coordination number cannot be generalized. Means we cannot say that the coordination number for every metal ion in the transition metal is same, or specifically, for example, 4, 5, 6, 3, 2, 1, etc. So then second is the stereochemistry of ligands. Stereochemistry of ligands means sometimes the ligands are bulkier in size, and if such large number of ligands are aggregating around the nucleus or metal ion, it is not possible to accommodate all such, or the number of such ligands cannot be accommodated in the given space around the metal ion. So depending upon the magnitude of these stereochemical interactions with each other between the ligands, the coordination number varies. So when the ligands are stereochemically varying, when the ligands are like this, the coordination number is low. Means when the ligands are bulkier in size, the number of ligands that can be arranged around the nucleus are limited, and that is why it is said that the coordination number is low. Means we cannot accommodate large number of ligands if their size is larger. Size of the ligands is larger. Then third point is that high coordination number most likely is possible. High coordination number is possible when the metal ion is larger in size. When metal ion is larger in size and ligands are smaller So coordination number is high when the metal ions are smaller in size, metal ions are larger in size, and ligands are smaller in size. So we have to remember these important things. Then the size of metal ion decreases with increase in the oxidation state or charge on the metal ion. Coordination number means we consider size of metal ion increases, or in other words we can say decrease with charge, increase with charge increase. For example, Fe2 plus is larger in size than Fe3 plus. So the size of Fe2 plus is larger, but when one more electron is lost, that is in case of Fe3 plus, the size decreases, and this matters the coordination number. Then next point is fifth point, which explains about the lower coordination number, which explains about low coordinations are favored by metal ions in higher oxidation state. Fifth point, low coordination numbers are favored when favored by metals or metal ions in high oxidation states and or with pi bonding. With pi bonding ligands. For example, if we consider platinum 4 plus and platinum 2 plus, so this is higher oxidation state. This platinum has higher oxidation state, so coordination number is here lower, so it has low coordination number, and this has high coordination number. Because of the size of ligands. Then we will see the actual arrangement of the ligands around the metal ion and the geometries associated with such arrangements. So we will see some examples of the arrangements. So we will show here the coordination number, then arrangement of ligands, and less common arrangements. Less common arrangements. So if we see the coordination number 2, the arrangement shows that there are two ligands and which are arranged at 180 degrees from each other. So the arrangement is linear. So there is no less common arrangement. When the coordination number is 3, the arrangement is called trigonal planar. So there is only one type of this arrangement. So when coordination number is 4, there are two types of arrangements: the tetrahedral and second is square planar. So in this case, when the arrangement is trigonal planar, the alternative arrangement here is sometimes less common, trigonal pyramidal. Then when coordination number is 5, the arrangement is trigonal bipyramidal. And another is square based pyramidal. Then next is 6th. When coordination number is 6, the arrangement is called octahedral. here the less common arrangement is trigonal prismatic. Trigonal prismatic. Then when coordination number is 7, the most common arrangement is pentagonal. Pyramidal. Pentagonal bipyramidal. So in that case, sometimes less common arrangement is monocapital, trigonal prismatic, and monocapital octahedral. Monocapital octahedral. So there are such two types of arrangements when coordination number is 7. When coordination number is 8, the arrangement is most commonly observed is dodecahedral. Dodecahedral. Square antiprism. Square antiprismatic. Prismatic. Then hexagonal bipyramidal. Hexagonal bipyramidal. So these are most commonly observed arrangements, and the less common arrangement is cube. Then bicapital, trigonal prismatic, trigonal prismatic. When coordination number is 9, the arrangement is tricapital, trigonal prismatic, so we will see some of these examples and what are their structures in next part of this topic. So we'll stop our discussion here. See you next time. Please subscribe to this channel and press the like button and bell icon. Thank you very much for watching this.